You will be perfectly equipped for taking measurements at supply air and exhaust air outlets of a room ventilation system with the Testo 417 vane anemometer. It can be combined with two funnels, allowing volume flow measurement at grills and diffusers, and thanks to the Testo Vent 417 volume flow straightener, it is also suitable for swirl outlets. But the right equipment is only half the job. In this video, we will show you how to measure correctly at supply air, exhaust air, and swirl outlets with turbulent flows. This is how you measure properly at the supply air outlet. When measuring at the supply air outlets, take into account that different flow rates occur at the outlet area because of the air outlet grill. This is why the vane is moved across the ventilation grill in loops. The Testo 417 automatically generates a timed mean value. In the process, make sure not to block the air outlet unnecessarily, because any flow resistance affects the measurement result. The best method is to move the vane across the grill surface at a distance of 5 centimeters. Vanes with 100 mm diameter are better suited to measuring than instruments with smaller vanes, as the flow values are integrated and averaged over a larger area. Integrating the same area with a smaller vane takes significantly longer. The Testo 417, when used with the optional measurement funnels, allows you to measure at standard supply air outlets with more accuracy and speed. This is because you have to make sure the cross-section of the ventilation outlet is traversed at a constant speed with the looping method. With the funnel, on the other hand, the different air velocities are averaged. Therefore, the funnel allows you to complete measurements faster. This is how you measure properly at the exhaust air outlet. A funnel is required to measure the exhaust air. The reason? There is no directed flow profile available for exhaust air as the air is sucked in funnel-like from the room. This means there is no definable area in the room via which the volume flow can be determined. This challenge is easily solved with the aid of the Testo 417 funnel. This is because the funnel creates defined flow conditions at some distance from the plate outlet in a fixed cross-section. This is how you measure properly at the swirl outlets. Measuring the volume flow accurately at swirl outlets is often a challenging task because the supply air is fed into the room in a circular motion, making an accurate measurement difficult. Why is that? Vanes can only record the flow accurately if the airflow hits the vane vertically. The flow straightener ensures that the airflow passes over the vanes in a single direction. Let's take a closer look at what happens. 1. The direction the swirl rotates is the same as that of the vane. What happens? The flow hits a larger cross-sectional area of the individual blades of the vane. This makes it accelerate too fast. 2. The direction the swirl rotates is the opposite to that of the vane. What happens? The flow passes between the individual blades of the vane. This means it doesn't accelerate properly. Result: an inadequate flow velocity is displayed. What does the flow straightener do now? With the patented Testo Vent 417 flow straightener, any rotational movement of the air is first calmed and changed to a straight flow direction. This directed airflow is then reliably recorded with the vane. That way, the most accurate measurement results are achieved quickly and easily. Let's summarize which measuring tasks you can carry out with the Testo 417. 1. Measure faster at standard supply air outlets. 2. Achieve accurate values at exhaust air outlets. 3. Achieve utmost accuracy at swirl outlets, even with turbulent airflow.